Good morning, everybody, and once again, welcome to Pankaj's Echelon Tutorials. And today we are going to continue with our previous videos. So today we are going to do exercise 3.2, and we had done up till question number 6, I suppose. No, 5. Question number 5 was completed. So question number 6 we are going to continue from today's video. Okay, now to remind you, this exercise 3.2 is from chapter number 3, which is Indices and Surds. Okay, and this is from the book by Sue Pemberton. Okay, and the name of the book is Additional Mathematics, and this is for the IGCSE and the O levels. Okay, this is for the 10th grade students, right? So with this as the background, let us start with question number 6, sub question A. Question number 6 is solve the following equations. Now all these equations that we are being solving in this exercise 3.2 are all exponential equations. Okay. So question number 6, sub question A reads that it's a 3 raised to a 2x multiplied by a 2 raised to a x equal to a 1 by 18. Fine. Chalo. Now let us try to solve this question. Now this is 3 raised to a 2x into 2 raised to x equal to 1 by 18. If you want to solve this, what can be done? Now this 3 raised to a 2x into 2 raised to a x I'm keeping as it is, and this 18 I'm writing as 18 raised to minus 1 because this is 18 raised to 1 in the denominator. When I bring it in the numerator, it will become 18 raised to minus 1. Okay. Now, what can be done? Now, what I will do is I'll try to split this 18 into, say, 9 into 2. 18 can be written as 9 into 2 raised to a minus 1. Okay. This I am keeping as it is 3 raised to 2x, 2 raised to x. Okay. Now, what I will do is this 9, I will write it as 3 square, and this I'll be writing as 2 only, and whole raised to minus 1. Okay, here I am taking 3 raised to 2x into 2 raised to x. Okay, now what I'll do is I'll multiply this out, minus 1 with this 3 raised to 2, so it will become 3 raised to 2 into minus 1 is minus 2, and times this will be 2 raised to 1 into minus 1 is 2 raised to minus 1. Okay, and this I am keeping as it is 2x and 2 raised to x. Now you can see that the bases, are equal. Okay, and so I can equate the powers. Okay, so if I see these two bases 3 and 3, they are equal on both the sides, so 2x can be written as minus 2. The powers can be related, I mean they can be equated. So 2x equal to minus 2, this gives me x equal to minus 1, right? Now if I take this, okay, this 2 and 2, here again the bases are equal, so I can also equate the power and write x equal to minus 1. But both the ways I am getting x equal to minus 1, so the solution for x is for this equation is x equal to minus 1. Okay, so either you take the help of 3 as the base and equate the powers, or you take help of 2 as the base and equate the powers, you are getting the same answer for the x. Okay, and this x equal to minus 1 happens to be a common solution. So that is the solution for this question number 6, sub question A. Now let me check out the answer behind in the book, and the answer behind in the book is given as question number 6A, minus 1 is the answer. Yeah, so we are correct. Now let us go for B, sub question B. Now sub question B is 2 raised to a 2x times 5 raised to a x equals 8,000. Okay, now this 8,000 somehow I'm going to write in the form of 2 and 5. Okay, so this 8,000 can be written as 8 into 1,000, right? Then this 8 can be written as 2 raised to 3, and this 1000 can be written as 5 raised to something, right? Now, can I write that way? Okay, 1000 I will write as uh, 5 into 2. Okay, 5 twos are 10 and into 100. Okay, 5 twos are 10, 10 into 100 is 1000, right? See, I'm trying to convert this right hand side in the form of 2 raised to something into 5 raised to something. So at least 2 raised to something I got here. So I'll be getting 5 raised to something as well. Now this 2 raised to 3 into 2 raised to 1, I can write as 2 raised to 3 plus 1, 4. And this is 5, and this 100 can be written as again 5 into 20, isn't it? 25 is 100. So now I'm getting 2 raised to 4 and 5 raised to 2 and into 20. Now this 20, I'm going to write 5 into a 4. So now I'm getting 2 raised to 4 into 5 raised to 5. 2 plus 1 is 3. And this 4 can be written as 2 square. So ultimately I'm getting 2 raised to, this is 4 plus 2, 6, and 5 raised to a 3. Got it? So all this I have done with this 8000 so that I get something in the form of 2 raised to something into 5 raised to something. Now my left hand side was 2 raised to 2x into 5 raised to x. Can you see the left hand side and right hand side? Now on comparing this left hand side and right hand side, when the bases are equal, the power has to be same. So you can see a 5 is the base on both left hand side and right hand side. So I can write x equal to 3. And if I want to compare using the base as 2, I can write 2x equal to 6. Or I'll write 2x equal to 6. This will also give me x equal to 3. So my answer for the B question is x is equal to 3. Okay. So I can write here 2x into 5 raised to x. This will go on. Okay. That was sub question B. Now let us go for sub question C. Now C says that 5 raised to a 2x times of 4 raised to a x equal to 1 upon 1000. Now, first of all, I'll take this 1000 in the numerator and write it as 1000 raised to minus 1. Left hand side I'm keeping as it is. Okay. Now, I'll try to bring this 1000 in the form of 5 into 4, right? So let us see how we can do that. So 1000, if you want to write it in terms of 5 and 4, so 5 into 4 is 20, right? So 20 times, how much should be 1000? 20 times 5 and then 50. 5 twos are 10 and then 2 zeros. Okay. So 1000 can be written as 20 into 50, right? Raised to a minus 1. Now this 20, I'm going to write it as 4 into 5. And this 50, I'm going to write as 25 into 2. Right? 25 into 2. 5. Okay. 4 raised to a minus 1. Right? See, 20 I have split into 4 into 5. 50 I have split into 25 into 2. Okay. Now what I'll do is, this 4 into 5, this 25 I'm going to write as 5 square. Okay. This 2 I'm keeping as it is. This 5 I'm keeping as it is. And 4 I'm keeping as it is. Okay. Raised to a minus 1. Right. Now, I'm getting 4 twos are 8, but I want in terms of 4, right? 4 fives are 20, twos are 40. Okay, now this 4 fives are 20 into 2 is 40. 40 into 5 is to 2, I can write. Okay, 4 fives are 20, 20 twos are 40. Now this 40 I'm going to write as 4 into 5, 40. 4 fives are 20. Okay. Into, now something is missing out. I want in terms of 4, right? Or rather, if I'm not getting 4, well and good. It will be 4 into, okay, then let me stick to this only. Uh, let us not go for this, okay, fine. So now this can be written as 4 2s are 8 into 5 raised to a 3 whole raised to a minus 1, okay. Then this 8 raised to 1 and minus 1, this will make it 1 of 8 raised to minus 1 into 5 raised to 3 into minus 1 will be 5 raised to minus 3. Okay. Now let us see what is happening. Now here on the left hand side I have 5 raised to 2x and I have 4 raised to x. Okay. Now let us see if I equate these two. Okay. If I compare these two, 5 and 5 on the left hand side, I can write 2x equal to minus 3 and that will give me x equal to minus 3 by 2. Okay. But here I cannot do any comparison because there's a 4 over here, there's a 8 over here. Okay. So what I will do is, okay, one thing can be done. Okay, one thing can be done. What I'll do is I'll still work out further and something can be done. Yeah. Now this is what clicks to me. Now 5 raised to 2x, this 4 can be written as 2 square whole raised to a x. This 8 can be written as 2 cube whole raised to a minus 1 and this is 5 raised to a minus 3. Now I am getting all the bases same. Okay. Now see, this is 5 raised to 2x. This can be written as 2 raised to a 2x. And here you have 2 raised to a minus 3 and into 5 raised to a minus 3. Okay. Now I can see that the bases are equal on left hand side and right hand side. So I can equate the powers or the indices. Okay. So by comparing this 5 raised to 2x with this 5 raised to minus 3, I can very nicely write 2x equal to minus 3. And if I want to compare this 2, so I can write 2x equal to minus 3 again. Okay. So in both the cases, x equal to minus 3 by 2. Here also I am getting x equal to minus 3 by 2. So my answer for x is minus 3 by 2 or a minus 1.5. So that's the answer for sub question C. And with that, we have completed question number 6. Let us move on to question number 7. Question number 7 says solve each of the following pairs of simultaneous equations. Now, sub question A is 4 raised to a x divided by 2 raised to a y is equal to 16. This is first equation. Second equation is 3 raised to a 2x times 9 raised to a y equals 27. Now these are two simultaneous equations, but they are equations they are exponential equations because the terms are involved in exponential form. Okay. And you have to solve this simultaneous equation. So you have to get the answer for x and y. Now, how we are going to deal with this? So first of all, what I'll do is this 4 is this is equation number 1, this is equation number 2. Okay. So first equation I'm going to take as 2 square raised to x divided by 2 raised to y equal to 16. Okay. This will give me 2 raised to 2x divided by 2 raised to y equal to 16. Now this will give me 2 raised to 2x minus a y equal to 16, isn't it? Now here we have used the rule a raised to m divided by a raised to n is equal to a raised to m minus n. Okay, that rule I have used. So 2 raised to x minus y is equal to 16. From this, I can write 2 raised to 2x minus y equal to this 16 can be written in the form of 2 raised to 4, right? Now you can see that the bases are equal, so I can equate the powers and write 2x minus y is equal to 4. This is my equation number 3. Okay, so I have converted this exponential equation number 1 somehow into an equation which is not in the exponential form. Okay, that is good for me. Now same thing I'll do with this equation number 2. For equation number 2, what I will do is I'll write this equation as 3 raised to a 2x into 9 can be written as 3 square whole raised to a y equal to 27 can be written as 3 raised to 3. Okay. Now what I'll do is 3 raised to a 2x into 3 raised to 2 into y will be 2y is equal to 3 raised to a 3. Okay. Now what I'll do is 3 raised to, this is multiplication. So I'll be using the rule of product, that is 2x plus a 2y equal to 3 raised to 3. Here I am using this rule, a raised to m times a raised to n is equal to a raised to m plus n. Okay. Now you can see here the bases are same. So I can equate the powers and write 2x plus 2y equal to 3. And this happens to be my equation number 4. So again, equation number 2, which was in the exponential form, that was exponential equation. So that I have converted into an equation which is not an exponential equation. Okay. So 3 and 4 are the two equations which are same as equation 1 and 2. Only thing is they are now not in the exponential form. So when they are not in the exponential form, we know how to solve this equation simultaneously. Okay, we know. So let us solve this equation now. So 2x minus y equal to 4. This is equation number 3. 2x plus 2y equal to 3. This is equation number 4. Now what I'll do is I'll subtract this. So I'll put a minus sign over here. 2x minus 2x will go. I'll get a 0. Minus y minus 2y will give me minus 3y. And 4 minus 3 will give me 1. And this gives me y equal to a minus 1 upon a 3. So I got my y. Okay. Now what I'll do, this y ka value I'm going to substitute in this equation. So 2x minus minus 1 by 3. Now this minus 1 by 3 I have placed in place of y, isn't it? Equal to 4. So 2x plus 1 by 3 equal to 4. So 2x equal to 4 minus a 1 by 3, which is equal to 4 3s are 12 minus 1 is 11 upon 3. So my x should be equal to 11 upon 6. 11 upon 6. This is my x. So I have solved the equation and I've got the values for x and y as 11 by 6 and minus 1 by 3. Let me just check the answer behind in the book. And the answer correctly says that x is equal to 11 upon 6 and y is equal to, oh, yeah, minus 1 by 3. X is 11 upon 6, y is minus 1 upon 3. I suppose in the book it is it minus 1 upon 3 or 1 upon 3? I cannot, okay. It has to be minus 1 upon 3 because in the book I can see as 1 upon 3. No, it's not 1 upon 3. In the book behind, I'll tell you what has happened. In the book behind, this minus and this division sign both has got combined and it makes me read as y equal to 1 upon 3. No, but it's not like that. There's a gap over here. It's minus 1 upon 3. Okay. Anyways, so this is the right answer. Minus 1 upon 3 is my y and x is 11 by 6. Okay. Chalo. So let us move on to the next question. That is sub question B. Okay. Now for this sub question B, the equations are 27 raised to a x equal to 9 times 3 raised to a y. And another equation is 2 raised to x divided by 8 raised to y is equal to 1. These are my two equations, and as you can see, these are the equations in exponential form. So let us see what can be done. Now this 27, this is 1 and 2. Now first I'll deal with equation number 1. So equation number 1 can be written as 27 can be written as 3 raised to 3 whole raised to x. This 9 can be written as again 3 square, and this 3 raised to a y. Okay, this is equation number 1 that I'm trying to convert it into a non-exponential equation, right? This can be now written as 3 raised to 3 into x is 3x. This is equal to 3 and this is 3, so this will be 3 raised to 2 plus y. Okay, now here I am using the rule a raised to m into a raised to n is equal to a raised to m plus n. This is what I have used for the right hand side, and on the left hand side I have used this rule a raised to m whole raised to n is equal to a raised to mn. Got it? Now because the bases are same, I can equate the power and write 3x equal to 2 plus y. And if I arrange this, I'll get 3x minus a y equal to 2. This is my equation number 3, which is same as equation number 1. Only thing is equation number 1 was in the exponential form. Equation number 3 is just an equation which is same as equation number 1 but in a non-exponential form. Okay. Now same thing I'm going to do with equation number 2. So 2 raised to x divided by 8 raised to y equal to 1. This is my equation number 2. This I'll write as 2 raised to x upon 8 raised to y equal to 1. This can be written as 2 raised to x upon, now this 8 I'm going to write as 2 raised to 3 and then y equal to 1. Now this can be written as 2 raised to x upon 2 raised to 3y equal to 1. Now here I'm going to use this equation, this rule, that is a raised to m upon a raised to n is equal to a raised to m minus n. Now using this rule on the left hand side will give me 2 raised to x minus a 3y is equal to 1. Okay, but now I see that my bases are not becoming equal. Okay, but not a issue. This 1 can be written as 2 raised to 0 because anything raised to 0 is 1. So here I am using that law, anything raised to 0 is equal to 1 or a raised to 0 is equal to 1. So 2 raised to 0 is equal to 1. Now here there was already 2 raised to x minus 3y. Now you can see that here the bases have become same. So I can equate the power and write 3x minus 3y equal to 0. This is equating the powers. Okay. So x minus 3y equal to 0. This is my equation number 4. So I get this x minus a 3y equal to 0 as my equation number 4. Okay, now you can see that 1 and 2, which were in the exponential form, has been converted into counterparts of 1 and 2, that is 3 and 4, which are not in the exponential form. And this 3 and 4 can easily be solved simultaneously. Okay, so what I'll do is this equation number 4, I'll multiply by, say, 3. So what will happen? This will become 3x minus y equal to 2. This is my same equation number 3. And 4, because I'm multiplying throughout by 3, it will become 3x minus 3 3s are 9y equal to 3 into 0, 0. This is my new equation 5. Now, I'll solve these two equations, 3 and 5. Okay. What I'll do is I'll subtract, okay, and see what I get. 3x minus a 3x is 0. Minus y plus a 9y. Minus y plus a 9y will give me 8y. And 2 minus 0 will give me 2. So this gives me 8y equal to 2. So y is equal to 2 upon 8, which is equal to 1 upon 4. So I get y equal to 1 upon 4. Now if I want to get x, I'll put this y value anywhere in these equations. either 3, 4, 5, whatever. I find this convenient. Okay. So x minus 3 into y value is 1 by 4 that I got equal to 0. I'm using this equation number 4, right? X minus a 3y equal to 0. So x minus 3 into 1 by 4 equal to 0. This gives me x minus 3 by 4 equal to 0. That gives me x equal to 3 by 4. So my both the values I've got x equal to 3 by 4, y equal to 1 by 4. I'll check the answer behind and verify whether it is correct or not. And the answer for my 3.2, okay, B question, yeah. X is 3 upon 4, which is correct, and y is 1 upon 4, which is again correct. Okay. So A and B are done with. Let us go for the C. Now question number C, sub-question C says that 125 raised to a x divided by a 5 raised to a y equal to 25. This is one equation. Second equation is 2 raised to a 3x multiplied by 1 upon 8 raised to whole raised to a 1 minus y is equal to 32. Okay, these are the two equations, right? Now first, as usual, what I'll do is try to make them in a form which is not exponential. So what I'll do here, 125, I'm going to write it as 5 raised to 3 whole raised to x divided by 5 raised to y equal to 25. I'm going to write as y square. This I'm going to write as 5 raised to 3x divided by 5 raised to y equal to 5 raised to 2. This I'm going to write as 5 raised to 3x minus y equal to 5 raised to 2. Now because the bases are same, I can write 3x minus y equal to 2. Right? This is my equation number 1. Now, or rather, this is 1, this is 2. Let me take this as 3. Okay. Now here again I'm going to do the same thing. 2 raised to a 3x 3x into this 1 upon 8. I'm going to take 8 on the top and make it 8 raised to minus 1 whole raised to a 1 minus y. This 32 can be written as 2 raised to a 2 to the 4, 4 to the 2 raised to 5, I suppose. Okay, because 2 raised to 4 is 16, 16 to the 32, so 2 raised to 5. Fine. Now this can be written as 2 raised to 3x, and this 8 I can write as 2 raised to 3 and then raised to minus 1 and then raised to a 1 minus y. This is equal to 2 raised to 5. This will give me 2 raised to a 3x into, now this 2 raised to 3 into minus 1 will be minus 3, and minus 3 multiplied by 1 minus y. Minus 3 multiplied by 1 minus y will give me minus 3 plus 3y. Okay. So this entire term can be written as 2 raised to a minus 3 plus 3y. This is equal to 2 raised to a 5. Got it? Now, here I am going to use the first law and write 2 raised to 3x, first rule rather, of indices. So 3x plus a minus 3 plus a 3y equal to 2 raised to 5. This will work out to 3x plus into minus is minus 3 plus 3y equal to 2 raised to 5. This can be written as nothing. Okay. Now because the bases are same, I can equate the powers. And if I do so, I can write this powers ka equation as 3x minus 3 plus 3y equal to 5. If I bring this 3 over here, 3x plus 3y equal to 5 plus 3, 8. Now this is my equation number 4. Now this equation number 4 I'm going to write just below equation number 3. So 3x plus 3y equal to 8. This is my equation number 4. Right? So equation number 1 and equation number 2 are now converted into equation number 3 and equation number 4, which are the counterparts of 1 and 2. When I say counterpart, means they are same as equation 1 and 2. They are same as equation 1 and 2. Only thing is equation 1 and 2 were both in exponential form. Equation 3 and 4 are not in the exponential form. And it is easy to solve the equations when they are not in the exponential form, particularly simultaneous equations. Okay. So that is what I have done. Now let us solve this equation 3 and 4, which are in the non-exponential form. Okay. So what I'll do is, again, here I'll do subtraction. 3x minus 3x will give me 0. Minus y minus 3y will give me minus 4y. And 2 minus 8 will give me minus 6. So my y will be equal to minus 6 upon a minus 4. Minus minus will get cut out. Okay, and I'll get 3 upon 2, plus 3 upon 2. So I get y is equal to 3 upon 2. Now if I want to find out x, I'll plug in this value in any of a convenient equation. So let me plug it in this equation number 3. Okay, so 3x minus, instead of y, I'm going to put 3 by 2 equal to a 2. Fine. So 3x minus 3 by 2 is equal to 2. So 3x will be equal to 2 plus a 3 by 2. So 3x will be equal to 2 to the 4. 4 plus 3 is 7 upon 2. So x will be equal to 7 upon 6. So I get my answer as x equal to 7 upon 6, y is equal to 3 upon 2, and I'm going to check and verify whether the answers are correct. And if I see the answers behind the book given is x is equal to 7 upon 6, that's what I got, and y is equal to 3 upon 2, again that's what I got. So this was the C sub question of question number 7, and here I'm going to end this video because again the time doesn't permit me to go any ahead, and question number 8, 9 and 10 will be doing in the next video. So goodbye everybody till then, and take care all of you. See you in the next video with the remaining 3 questions. Bye, take care all of you.